channel Analytics and Beyond, and today we are going to discuss on conditional probability. And today topics hands-on conditional probabilities, definition, formula and practical exercises. So first let us understand what is a conditional probability. Already you know the definition of what is a probability. I have discussed in the previous videos. If you want a clarification, you can go back. Probability means we are just assuming something, it may occur. So that is a probability. So after assuming, I need some equations to draw it properly to make it accurately. So we are applying some conditions on that probability, that we call it as a condition probability. So how would you define conditional probability in terms of formula? Let us see that. So here I have taken the two events. Let A and B be two events. Then how would I define the conditional probability? If A and B are the event, okay, then B is an event. So if I want to define a conditional probability, then I would define like this. Probability of B is given that A is probability of happening of B when A has already happened. That we call it as a conditional. In simple words, I can say that B knows about A. So that is the meaning of conditional probability. B already know about A what is going to happen. So that is conditional. So next comes a probability of happening of B when nothing is known about A, unconditional. Unconditional means B does not know anything about A. But you can't write that in a paper. So we can't write that A knows B. Conditional, B does not know about A. Unconditional. So you have to write in this verse itself. But for your understanding, I'm just giving you an example. Then after defining conditional and unconditional, there are certain equations to prove it, right? When you write theory, no one will accept. For acceptance of conditional and unconditional probabilities, we have to draw some conclusions. You have to draw some equations and prove it. So how to do that? Here it is given. Probability of B, that B knows A, B occurrence of A, so that you can give it as probability of A intersection B divided by probability of A, provided that probability of A greater than 0. What is the meaning of probability A greater than 0 means? Nothing but A has already happened and B knows it. Greater than 0 means it is happened. Okay, that is the meaning here. So how will you prove that happened? So by this, when you solve the problem, you will get to know it properly. So for time being, just remember this formula. You'll solve the problems and get to know it. Then one more example, one more thing we have to conclude that. So if it is greater than 0 means this is the condition. If it is equal to 0, that means A does not happen. If A does not happen means we can call it as an unconditional probability, and it is declared that probability of B of A is not defined. We cannot come to a conclusion. If A happens, we can come to a conclusion. If A does not happen, then we cannot come for any kind of conclusions, right? So that is, no, in better example I can tell A is raining, B is cloudy. So B knows A means B is cloudy and it is raining. So we can come to conclusion. B is not defined. A is only cloudy. We don't know what is B means. We cannot define it. So that is unconditional. Right? So next is, so that we call it as a conditional probability. Under conditional probability, there are two things. Probability of A greater than 0, equal to 0. What you have to do it. Okay, in problem, if they give one A and one B, then we can solve. If B is given and A is not given, you cannot solve. You can just directly write it as not defined. So now B will be independent of A. Now independent, if the B is an independent means B is not dependent on A. Here these are all dependent events. That is B is depending on A, right? So here B, if it is independent, then this is the formula. Probability of B is probability of A intersection B divided by probability of A. This intersection. So same formula, but the thing is here B is dependent on A. Here it is B, probability of B equals that. We have not written dependent on A because these are the independent event. So how will you get independent event. So we can tell this B is independent of A. I can tell this. How can I tell two events A and B are independent? If and only if probability of A intersection B is probability of A into probability of B. So this they may ask for 5 marks. Explain the conditional probability. Then you have to explain this conditional probability, definition, explanation. Then the three things what we have declared here. 1, 2, 3. Both. You have all the three have to explain it. So now you will get clear when we solve the problem. So let's solve. So here is a problem given based on the conditional probability. First you need to identify and you have to solve because you have to identify whether it is a conditional probability or general probability. For identification problem itself, they have given that one condition they will give, that one of the children is boy. One thing is confirmed, another thing is not confirmed. That means it is a conditional probability. If this is not given, then normal probability problem you can solve. So problem is the family has two children. One of the children is boy. What is the probability that other is also a boy? So two children are there. One is confirmed. That means B is confirmed. Is not confirmed. So for that, now what is the formula that you have to use it? So before that we will write consider the two events. Let so B be the event that one child is boy. So always we have to take one condition. Whatever condition they have given, consider that as probability of B. Okay. B is one child. A is, they are asking the question, what is the probability other is also boy? So other is also boy means both children are boys. So these are the two events, B and A. So now apply the formula. What is the probability? So here just I'll write the possibilities are. So what are the possibilities? So they are asking what is the probability that other is also boy. So I'll write the possibilities are. What are the possibilities? So of other is a boy. So probabilities are BB. Both can be boy. And one boy, one girl can be there. And girl, one boy can be there. And both are girls. So these are the probabilities. So that will be equal other one they are asking. So divided by 4 possibilities. It's similar to tossing a coin. So they are asking about another boy. So one, what is that one combination? Okay, out of two children. So that is 1 by 4. Then apply the formula. So what is the formula? So before that, let us assume that possibilities are. So what are the possibilities of other boys? So both can be boys. Both can be boys. One boy, one girl, one boy. So it could be 1 out of 4. Then what is the formula? Probability of A union B equals probability of boy. What is a boy? 1, because they are asking 1. So I have written 1 by 4. And the other chances. What is the probability of other is also a boy? So out of 1 by 4, what is the other chances? Like BB, BG and GB I have taken. GG I have excluded because they are not asking about the girl, boy. So 3 out of 4 combinations we have. Now directly we will go and apply the formula of probability, conditional probability. Since these two are independent events, I'll write probability of B equals, so same formula I'm writing for independent event. So probability of, I'm just copying, probability of A intersection B divided by probability of A, right? So just substitute this. So what will be the probability of B? Probability of B equals, what is the probability of A union B? That is 1 by 4. So here we have written A union B, probability of B, right? So 1 by 4. So same. So this is 1 by 4. So I am writing this 1 by 4 divided by probability of B, probability of A. So what is the probability of A that they have asked here? This is nothing but A, because possibility of the other is also boy. This is event A. Okay, other is also boy A. That is 3 by 4. So divided by 3 by 4. Right? So when you solve this, so while taking the reciprocal 1 by 4, this becomes into, okay, 1 by 4 into 4 by 3. Alright, while taking the reciprocal. So just zoom this. Okay, 4 by 3. So 4 get cancels. Equal to 1 by 3. So 1 divided by that will be equal to 1 divided by 3. So when you divide 1 by 3, you will get 0.333 something. So that we will conclude it equal to 1. So what is the probability of getting other is also a boy is 1. So at 0.33. Okay, we have another problem here depending on same on the conditional probability. So previous problem was about the independent event. Now this is a dependent event. I will just check. Okay, this is second one. 10% of bulbs produced in a factory are red color. So 10% are red color out of 100, and 2% are red and defective, and one bulb, and if one bulb is picked at random, and if I pick a one bulb at random, determine the probability of being defected if it is red. So they have manufactured red bulbs in a factory. Out of that, 10% are red and 2% are red and defective. So both possibilities. What is the probability that if I pick red, it should be defective? So we have written here, let A be red, B be the, so I'll write capital B here, B be the red as well as the defective. So what is the possibilities of A? They have only given 10%, that is 10 divided by 100. So this becomes, so 1 by 10, I'll take it as it is. Then what is the probability of red and defective both? So A is red. So B, instead of taking it as red and defective, let us take defective so that you will not get confusion. So that means intersection, that A as well as B, both possibilities, that is 2%. So I just take 2 divided by 100. So that I can keep it as 1 divided by 50. Okay, kept it. So now they are asking, determine the probability of being defective if it is red. If it is red, what is the probability of being defective? So this is the formula that A has already happened. B knows what is happening with A, because A is the red color bulb and B is the defective. So they know what is going to happen. So this is a formula for finding the probability. So A, probability of A intersection B divided by probability of A. So just you need to substitute here, equals, what is A intersection B? So what is A intersection B? That is 1 divided by 50. 1 divided by 50 into what is probability of A? 1 by 10 divided by 10. After taking the reciprocal, so you will get 1 divided by 5 as the answer. So what is the probability of bulb that is being red and defective? Equals 1 by 5. You can simplify and write it, or if you want you can simplify, or you can keep it as it is. We have another problem here. 2 dice are thrown together. Let A be the event of getting 6 on the first die, B be the event of getting second on the second die. Are the events A and B independent? Now you have to prove both whether the A and B are independent. So what is A? First let us define what is the event A. So what they are asking first die, when 2 dice are thrown, remember 2 dice means 36 combinations will come. So first die will be 6, 6, 1 you have to write. Okay, next you have to write 6, 2. So like that, keep on writing. So okay, I have written 6, 1, 6, 2, 6, 3, 6, 4, 6, 5 and 6, 6. So now coming to event B. So second means B, event of getting 2 on the second one. So second one should be 2. So how will we write this? Just okay. So just we will write it as 1, 2. Second one is 2. So keep on writing 2, 2. Yeah. Next second one is 2. So 3, 2. Then okay, done. So now both are done. So now we have to find out whether in order to make them independent. So what is the condition? A should not depend on B, or B should not depend on A. So that is the meaning of independent. So here intersection, what is the intersection? 6 and 2. How many combinations we have? 6 comma 2. So that we will write if there are any intersection, that we have to write it just to prove that they are independent. Okay. So I'm writing independent. Then what is the probability of A? That means occurrence. 6 possibilities out of 36. Then what is the probability of B? So B is 2 is occurring on the other side. Okay. So 2 is nothing but probability of B that occurred is 1 divided by 36 can happen. What is the probability of A intersection B? So already we have written it, right? So now here, so I have written 6 by 36, so that is 1 divided by 6, and B is also 1 divided by 6. So 1 possibilities. So probability of A intersection B, that means how many possibilities we'll get. So that we can write it as probability of A, what is the formula, into probability of B. That is the formula just to prove whether both the events are independent. So let us prove it if A and B are independent. That we have to prove. So I'll take LHS as probability of A. So same thing, I'll just copy here. So this is 1 divided by 36. Okay. So now here, so RHS, what we have to prove is probability of A into probability of B, we are proving it. So that is equal to, what is probability of A? 1 divided by 6 into 1 divided by 6. So that is also equal to 1 divided by 6 into 6 is 36. So L and B, RHS and LHS and RHS are similar. So this is also 1 by 36, right? And this is also 1 by 36. So this means both are equal. So that it is proved that events A and B are independent. If they ask whether the events are independent, then compulsorily you have to apply this formula, okay, for independent event. In the question, in case if they ask independent, you have to write this. So this is how you will solve this problem. So just think about probability of A, B, and then substitute. So that's about the conditional probability. Please do like, share and subscribe. Thank you.